Welcome back to Engineering Economics. We are going to continue with the idea of using the goal-seek function, but now we're going to look at when we have more than two alternatives. So this example says a pressure vessel can be made out of brass, stainless steel, or titanium. The first cost and expected life for each material are the following. So I have a brass option that costs $100,000 that lasts 4 years, a stainless steel option that costs $175,000 for 10 years, and a titanium option that's $300,000 that lasts 25 years. Okay, the pressure vessel will be in the non-radioactive portion of a nuclear power plant that is expected to have a life of 50 to 75 years. So meaning for any of these options, I'm going to have to replace it. The Public Utility Commission and the power company have not yet agreed on the interest rate to be used for decision making and rate setting. Build a choice table for the interest rates to show where each material is best. Okay, so up until this point, we've been told use a net present worth, use an equivalent uniform annual worth, and this one is pretty open-ended. We're not told exactly what to use. Because my design lives are so different and they're not even multiples of each other, I'm going to move into using an annual analysis. I think that makes more sense to kind of compare it year by year. So that's what I'm going to do, and I'm going to use equivalent uniform annual cost just to kind of show you the difference. We've already done one with equivalent uniform annual worth. I want to show you how this one would look. So I'm going to rewrite all of this data just in Excel so the values can be referenceable. So I have the brass cost and life, stainless steel, and titanium. Okay, so step one then is going to be to create an equivalent uniform annual cost for each of these. And once again, I'm going to graph it. If you remember in our first few videos in this chapter, we talked about how in order to get a basis for where my intervals exist for my choice table, it's a good idea to graph everything first. So that's going to be what we do. Okay, so to get my equivalent uniform annual cost for my brass, you'll notice I up here did my factor formula, and then here I'm doing just my Excel formula. So it's going to be a negative PMT formula, okay, with my interest rate, and then my design life, and then my cost. So since the cost is a negative value, I'm going to leave it in here. Okay, so that is correct. Okay, so you'll notice I just made that positive. It doesn't really matter. So realistically, this means it's a negative. So what that means is this is going to be a cost every year, right? I mean, that makes sense. So that's why it looks negative. So just so that I can have kind of a basis to compare, I'm going to make it positive so I can look at it and just say, uh, this is what my cost is. I'm aware it's a negative value, but for me mentally, it's going to be easier to compare absolute values of costs than it is negative costs. I know that's dumb. Feel free to do whatever works for you. Okay, so I'm going to come in here and I'm going to make these absolute referenced. Okay, so you can see here that my equivalent uniform annual cost goes up over time. Okay, so now I'm going to do these other two kind of at the same time because I can. So I'm going to still go reference my interest rate, my stainless steel, and my design life. And then here, I'm going to do the same thing, just make sure it's referencing the right things. So I'm going to drag these over so they're referencing titanium. Okay. Okay, so then I will drag those two down. Okay, so this is what you'll notice my graph, I had it all ready to auto-populate. So this is my graph for these three options. So the green line is my equivalent uniform annual cost for brass. The purple line is equivalent uniform annual cost for stainless steel, and the blue line is my equivalent uniform annual cost for titanium. Okay, so if you remember, when I put a little note here, we want the lowest equivalent uniform annual cost because it's a cost, right? So I want to spend the least amount of money. So in the previous examples, we wanted to maximize the EUAW, but that's because it was a total value. So I wanted a higher total value, not a lower one. So if I look at it this way, basically what I want then is the lowest line during each interval, or the bottom line during each interval. So this one's a little different because I have 3 lines, right? But I want to find the bottom line or lowest line during each interval. So I mean, on one hand, I can come in here from the get-go and say, okay, this blue line is your choice for the first interval. The purple line is your choice for the second interval. The green line is your choice for the third interval. That's great. That's a good template. But now I need to actually find where those intervals are. And that's what I'm going to do using GoalSeek. So from the beginning to this intersection point is going to be titanium. From that intersection to that intersection is going to be stainless steel. And from that intersection to 20 is going to be my brass option. Okay, so now what we're going to do then is we're going to set this up using a GoalSeek table to find these intersection points. So we are going to just use 2 lines at a time. So for this intersection point here, I'm just going to be using the blue and purple lines. For this intersection point here, I'm just going to be using the green and purple lines. Okay, so let's go look to see how I have this set up. So you'll notice I come here and I have this set up kind of in 2 different tables. So one says GoalSeek Table 1 and the other is GoalSeek Table 2. And all I mean by that is in GoalSeek 1, I'm going to be using stainless steel and titanium. And GoalSeek Table 2, stainless steel and brass. Okay, that's it. Okay, so I'm going to, in this first table, say that if my interest rate is 0, this is what I get over here. So I'm going to come into my data, what if analysis, GoalSeek, and I'm going to say set this cell, which is my increment just of titanium to stainless steel. Remember, I'm setting them equal to each other. I'm going to set it equal to 0, and then I want to change my interest rate cell. Okay, and remember the 2 interest rate cells below it are both referencing cell B45. Okay, so as I run that, I get 6.3. So now we can kind of come to our graph and say that line equals that line at 6.3. That makes sense. That, like, I can use a gut check and say that looks about right. So now let's go to our second table. And for our second table, I'm going to do the exact same thing. I'm going to set these equal to each other, and by trying to force that cell equal to 0. So what if analysis, GoalSeek. So I'm going to set cell F54 to 0 by changing cell this one. Okay, so I hit enter and it gives me, you'll notice how it changed a couple times. It tells me 15.3. So now does that make sense if this intersection point is at 15.3? Yes, it does. So that looks good. Okay, so some of you might be having a little bit of a heart attack with these being negatives. Remember, I just flipped them. If you were to make those positives or absolute values, you'd get the same answer. Okay, so my choice table then would look like this. And this says infinity. We really only went to 20. So from 0 to 6.3, I would choose titanium. From 6.3 to 15.3, I would choose stainless steel. From 15.3 to 20, I would choose brass. Okay, so then we can kind of look at this. Does that recommendation follow? So titanium is the bottom line here, correct? Stainless steel second, and then brass third. Yep. Okay, so that is how we would use GoalSeek with more than one alternative. So bottom line to me, I would make a graph first. Make a graph, see which are the pairs you need to analyze, and then move forward from there.